get a big round of applause for every single shipper in this room. So I am looking at 35 glorious shippers who are going to be presenting 15 distinct CodeGen projects. We are going to run an unusual experiment today. Our project presentations, rather than being mere presentations, will be Q&A heavy. So the intent is that you have a deep, intense, and technical, egregiously technical interactions with the audience, all of whom are also shippers. And we are going to be demoing code bases. So please do dig into the guts of what it is that you've done. Demo your actual code, not just the performance of your application. And basically talk to us about the technical insights that are required to implement your code. So I know what you're thinking. I have these secrets, they're precious to me. They're things I know that nobody else does. They're my personal IP. How could I tell a room of 50 people about my glorious insights? And what I propose is a trade. You will give to us and we will give to you. You will come away with 15 novel insights. In exchange for your own, will become more powerful as a result. And ideally we'll gain an appreciation for the depth of the insights of the hackers that surround you, which will be the source of a kind of connection that can create the cooperation, which will actually leverage the community here to shoot your projects into the stratosphere when you break out to launch your company or to launch your new product. So please, intimate presentations only. Cheer and clap if you understand what I'm saying. Okay. With that, the first project is called the Automated Mathematician. Isn't that effing awesome? So, okay, I can't wait to see this. If you can't tell, I'm wearing a math jacket. So whoever's about to present this, I deeply sort of synth with your vibes all. Yeah, so if you're on deck, which currently is Tidal-Cycle-gen, please do come be prepared in the corner. If you're presenting, do please come here and present. Automated Mathematician, get up here. Let's hear it for Automated Mathematician.
Begin with this generative voice called the Queen. The Queen emerged from a high temperature exploration.
This is kind of like, think of it as kind of like a meta-modern, xenomodern art, okay? So I'm about to play the voice by the Queen, talk about our method, okay? So I figured it's a co-creation environment.
Slower and clear.
That is why the Queen exists, actually, communication bottlenecks.
Nice.
Let's go.
Multidisciplinary approach that integrates mathematics and computation to understand cognitive flows and their complex dynamics. For mathematical modeling, we rely on models based on the theory of complex systems and neural network theory.
I'll send the Queen over. I sent the Queen over airdrop here to a few of you over an MP3 like file with some information. So it's better.
Queen's lovely, but how many of you know what automated theorem proving is? Okay, so MetaMath 0 is like an old language for doing this. You can basically write a structured representation of a mathematical proof, and then run algorithms on it, check that it's valid, etc., etc. MetaMath 0 is basically a nicer version of that, slightly upgraded. So we have this thing, Continuum. This is like a retrieval augmented generation GitHub repo thing. So you can talk to a GitHub repo. And we put the spec for MetaMath 0 in here. So you can just see, this is a quick description of what it is. A couple of packages implemented here. We have a verifier. This is kind of the main foundation of this approach. So I guess to give the problem statement, the idea is, can you take a research paper and then convert it to a structured representation and then check that it's valid or not using a reliable symbolic representation? So paper to proof.
I have to say that co-creation is always like a generative creative tension. We all try to flood our sort of global workspace of deciding what to do. And so I decided to do Haskell, and really the way I see it is intuition binding. Okay, so you have some mathematician like Darius. Okay, he has an idea about proof. Just search space of all computable sort of proofs becomes your like sort of hyper-Boolean, like a sort of smaller space of computations. And if you really can express that intuition in a way that translates to some symbolic expression, like capture this sort of like inductive bias in some symbolic way, you significantly increase the likelihood that your intuitions, your vibes, will translate to some restrictions. So for reference, metamath is what's used in ZKVM, for instance, to provide proofs of like attestations to computation being run a certain way. What if you can do is you can reference this by its own hash, right? So you can say these proofs themselves become protocols, right? So in many ways, a lot of these things are now possible. And the story we went through is to generate this in some reliable way that's not just stochastic pairs, hallucinating. And so how do you generate with a grammar? What is a grammar for metamath? Like, what's Bacchus no form? Like, these are complex topics that might not have enough room to fit in this context. But if you look at information geometry and how do we design these like lost landscapes to have sort of position-dependent noise of a kind, how can we use our invariant sets to activate sort of attractors and talk about high-order functions? It's an incredibly complex, multi-scale, multi-layered sort of like view of what happens when you don't think about AI as separate from this, as a term in your ontology. So like AI anti-realism is how you address information decomposition with intention. So like you say, AI doesn't exist, how do I describe the system? So in this case, back to you.
Okay, so if you were following anything I was doing back there, we have this file, this is some proof. We have this verifier, this is a thing that can verify the proof. We're going to demonstrate that briefly. So we'll say, I don't actually want that one out there. Spec checked, it says error, this is actually just a warning. So we didn't give a proof, we just actually gave a statement. But it says spec checked, which is this thing we got here, these axioms.
It's a very fast operation.
And so anyway, this is not that interesting, all fairly standard. The interesting thing is, what if we take this real proof? So this is Lever's fixed point theorem. Doesn't really matter, but the idea is it's some complex proof that we have in a LaTeX representation here. And we take this. Bear with me, single-handed. And we put this in here. Run this one actually. And you say like, can you?
I can speak about vibes LOL, by the way. And so yeah, it's very vulnerable to sort of interact with this generative surface by text. If you try to introduce people to these systems, like product people who want to use these things to achieve something in the world, you don't just put them in front of a text box and say, what am I supposed to do, right? In this case, it's a sort of reflection, right? It's an intentional derivation, and you can treat it as a rewriting process, right? And so the notion that we have precision at these steps is that any number of these like autoregressive operations leading to a different model, maybe you paste it in the post somewhere, or this funny prompt that a friend sent you, leads to conditions for emergence, right, at the level of a mesoscale. And so we want to simply ask ourselves, can we actually do something to engineer for emergence? For what invariance, at which scale we can preserve, and is there something that sort of this predictive coding, global workspace theory, tell you about this idea of active inference? Can these agents actually decide, in some sort of reason about if you would warrant the agent ontology, which is what, again, is a question you have to ask. Can they make decisions on their own that come from common sense? And so Automatic Mathematician was a project that failed. It failed in a very special way, where a bunch of people thought very hard about this like recursive theory of computation. So if you don't take Turing machines, you do church Turing equivalence, get recursive functions, you get the point where you can start reasoning about how these systems in autoregressive mode operate from a computational standpoint. And so, but failure in this case becomes fuel for subsequent success. What all it is an n-1, when the only heuristic we had was some sort of probabilistic model of the kind. If we had this giant reservoir of knowledge, this organizational memory, and we're out of time. So, yes.
Awesome. So time for Q&A.
Yes.
Oh.
First of all, yeah, congrats.
Thank you.
First of all, yeah, congrats.
Thank you.
First of all, yeah, congrats. Anyway, so yeah, we're all actually going to be voting on who wins at the end. So do keep in mind their answers to these questions in each project. So I guess first question, how much of this did you do during the hackathon as opposed to before? And second question, can you show us the constraint that you put on the grammar that is generated by the LLM? Because I think a lot of us care about generating JSON or generating pure code or having typed generation, and whatever constraint system you use might be generalizable to other kinds of output.
Yeah, so also this is sort of like a notion of what is the correct way of constraining generation and at which level does it happen. So obviously if we have a fast operation of checking for well-formed syntax, we can do it like as a search of a kind, or we cut out certain things that are not valid quickly. Run it for a few times. In fact, last time I hacked the AGI house was in February. I was working on symbolic memory for LangChain. It's like, what if we have this chain of thought, but we compress our world model as like a generative process rather than a lot of data? Like, so what does it mean to have a generative model? Allow accessories to connect. I suppose that's the way to do it. Just say no. And so what we did, in fact, is explored several approaches. One of those is this approach from Llama CPP, popular library for running local sort of systems. The decentralization of information architectures is not a matter of ideology, it's just information locality, and so we picked this one. And if you wanted to see grammars that are available here are several of them. And so to give you an idea, I can run it as well, but we can simulate this in our head, right? So let's see, grammars, we don't need computers to have constructions that are viable, sort of like postures or motifs of these temporal hypergraphs, right? Which is a little self-referential. We've discussed the preconditions for autopoiesis, right? The self-organizing, self-maintaining system that through sort of recurrence of itself through simple dynamical equilibrium, sort of distributive structure of guidance. So now we have these like flow networks that I want to say we can now proceed to create cognitive twins of ourselves, right? Cognitive twin is nothing more than a digital twin plus some sort of representation of knowledge or belief, right? And a replay of surface, right? If you look at generative flow networks, for instance, or any sort of diffusion distributive process that allows for you to encode your distributive structure as like Fokker-Planck equations, for example, is one way of doing it stochastically, or in some say structurally. Then you arrive at this ability to generate the geometry of the data that you work with, and so if you are constrained by informed things, you can engineer around like mirror symmetries, for instance, with chirality. Yeah.
Does that have to do with token limits, or?
It's a slightly more subtle, kind of like more direct way to experience this when you have sort of like a lot of communication with friends, and we own the line on like the model of the world, right? There's a lot of heat, wasted energy, right? So when we actually spend time to enable a lost landscape of a cognitive manifold of like our encoding of the world, like some sort of world model, and we have some sort of symbolic structure as well as a common sense sort of stochastic structure. This neurosymbolic architecture is much more interesting. And so Mathematician is a twin, right?
Congrats. So that is automated Mathematician. If you have more questions for our phenomenal presenters, they will be here after the presentations.
Hello there, everybody. So I decided to do something a little different today. Does anybody know what tidal cycles is? All right, so basically it's well, let's go through. It is a programming language where you do live coding for music within it. That probably would have been better if it started as soon as I hit it. Okay. Okay, but going on, it's pretty much, yeah, like a live programming language that you run and you write as it go live, and I always wanted to work with it. And I always thought like code generation for something like a live music. Who here has seen AV Club SF before? They're a group that does this. They put on little shows and concerts about it. So I thought this would be a really cool project to try to do generative code of, as opposed to something like Facebook's Music Gen, in which case it creates the music for you. This creates the code that will create the cycles for you. I think a lot of the work this morning is I probably should have done more pre-work in terms of setting it up, going with the super collider. So how it works, sorry, it's very slow right now, is that basically there's a sound engine that they have, super collider, that you, oh yeah, that they put in, sorry, I'm just going through, not the best presentation time, but basically what it is, we're trying to generate this code on the computer to run this stuff with it, and one, there's not a lot of documentation on it, so it, like, the original stuff I tried with ChatGPT wasn't that good, so I fine-tuned it on my Works GPU cluster, in which case I can't access that right now. But basically I can show the results of that. Oh, this is...
What did you fine-tune?
Basically I put in Llama, and I gave it a lot of training data in terms of like, these are the VSTs in terms of sounds we have. These are the beats that you want to put in, and this is the structure that you want to go through. It always happens during presentations.
Is your computer crashing, or is the internet crashing?
I honestly do not know. If it goes down before it, all I want to do is play what it made for me. Real quick, let's see if I can get to it before it goes through. So how it does is this is a sound. Let me turn up the volume. Yeah, and which way to do it, it's like very specific through how it runs through in that, like that's a beat. And as a cycle, you can like compound them upon one another. Like this is super mandolin, and then from that, you go through that. And now let me just, not the greatest, but it's interesting that they put out back through it. There we go. And then stuff like this where like all I want to do is have a return for this and stuff like that. That like you play this and you would let the stuff different. Like you could turn this into like a G, if not like that. Like you would turn stuff like that into like a G6, overrun it, and then it goes through, like add stuff like 9, and it like takes a code snapshot and it overwrites it. Having it be able to write more things like this is like the next part of it. But yeah, stuff like that, that's the sort of code that I wanted. Alright, Q&A, sorry about that, Q&A time. Alright. No, it's not that common, but this is also written in Haskell, by the way. I think it's a really cool project. That I think it would be nice to put in something where like if you have like a front-end interface to it, like bring me something funky or bring me a cycle that goes through it automatically deploying and going through it. That's the sort of stuff. And then the second part of it would be the sound engine, in which case it actually gets a sound. You have to write code like this in the background, in which like where do you put the sound, where do you get the VSTs from it, and do you want any like audio drip from it, all that jazz from it. So it's like code upon code, and that's what I think would be a cool generation project that like I made some headway here, but not a finished project in terms of something I really want to like be like, oh, here's the model, put it out, and like we can do it automatically. Maybe next time at next hackathon, but yeah.
Yeah, can I see the fine-tuning data?
That's on my like computer.
Okay.
Can I put it? I can put that in at the end of the night, or like once I go back. But yeah.
Sure. Yeah, I'm just curious. Is it a JSON file with this kind of?
Yeah, stuff related. That was the hardest part. But yeah, I will message you on Slack with that specifically, Jeremy. All right.
Any questions?
Oh, I'll start in the back.
I've used Super Collider before. Confusing a little bit, but I guess how are you mixing that with the other library?
I haven't used Super Collider with code generation yet. I just used basics in terms of this is the sound that we go through. That's like the next step I want to go through in terms of code can mix up the sound like this. You can go into the really back end of the code. Because I also find Super Collider confusing. I'd go to a lot of forum posts and like make sure like this is the sound you want. But yeah.
Okay, cool. So I guess the code for this is the same as the other code you have?
Oh no, the other, like the pulsar code in terms of, I give it a format in terms of like for this cycle, this sound, give me like a cool chord or whatever. For this in the background, this stuff is hard coded. The stuff that I got to do at the end, this is generated. If a little fine-tuned, if a little spruced up, if the format was not great. But I think that's fine. But yeah. Right. Any other questions?
Yeah.
Thank you.
More questions?
Oh, sorry.
Give people time.
All right, any other questions?
Really? Everyone understands. No one's curious. How do I do this myself? Actually, I'm curious. Like this particular format of like music gen? I've never seen it before.
I found it at a show, and I thought it was like really cool because it was like live coding and music, and it's the sort of thing that like I think that could be really cool because stuff like Facebook's music gen does take time to like go through to fine tune and such. If you could go to a show and give it a word like give me something quirky or give me something ravey, and it gives you something back that you can just plug in and play and then like see through, that can be like a really audience interaction for an actual show, which I think would be really cool and fun. Sorry, question, yeah.
So can I find existing music in this format?
Yes.
Oh, okay.
Look up Pulsar and Super Collider.
Is it all ambient?
Cycles. It's mostly synths. There are even people who put stuff like mandolins or other VSTs onto there, but it was like a synthwave project in a way that I think you can add more stuff to. But yeah, the real Tidal Cycles, Super Collider, and Pulsar. Those are the 3 things you need to look up to do it.
I was just gonna say, there's this other DJ Dave, that does this type of coding as well, and she's super cool. She does tons of cool stuff as well.
I'll look her up. Yep.
Can you DJ our next party?
Of course. I'll hit you up on Slack.
Cool.
Got it. All right. Any other questions? Oh, sorry.
Can you generate more like story-based music, like classical, and like that kind of stuff?
I think eventually, yes. But yeah, that's a good thing. That's definitely on the roadmap and like my inner brain. But yeah. Okay. Cool. Thank you.
Phenomenal. That was Tidal-Cycle-gen. So we have sdgui. You're up. GPT Data Dictionary. Han, you're on deck. You come and hang out. You're done.
All right, hey everybody, I'm Travis, aka TMC Online, and what I set out to build today was basically putting up a web interface on top of small dev, and in particular, my fork of small dev, which is called Small Dev Go. If you're not familiar with Small Developer, the idea is that it is a program synthesis, LLM, maybe too much to call it an app, really simple script from Swix that basically, from a high-level description, markdown file, you get like a full program synthesized. Something that I found in porting it is that kind of like initial shot, like hope for the best, is not very realistic, and often an initial file generated isn't what you want. And so I'm going to kick this off here. I threw in a live title set gen. We had less time to work on the UI than we intended, but I'll talk through what you're going to see here. So if you're not familiar with Small Developer, it kicks off an initial prompt where it plans out what files to generate given the description of the program, and it also goes through a phase. So what you see in here is the initial file planning phase. You see that. It goes through a phase that you're seeing now, which is a phase of defining and making connections between dependencies or symbols within the generated code set. And then what you'll see, and what we really hope to show in like streaming in each file, but once this phase is done, you'll see, and again our UI time was a little low, that for all these files which are now pending, I think I set concurrency down to just 2 here, you can go much faster with OpenAI, but you'll see that, okay, live demo guides. So the intent here was that we wanted to render like a tree of files, and then the interactions we wanted to support were blow away this one file. So the implementation here is basically building a GraphQL schema on top of the capabilities that Small Dev and Small Dev Go supply. And the ultimate goal, we got less far than we intended to, is to support an initial generation, but then an iterative process where you amend your initial prompt. You say, this file should be not included at all, this file should be regenerated, these files should be added. And so the net intended result here, again, should have gone further. Net intended result is to have this tool to not produce a final result on the first generation, but to support you in a process of iterating. I don't think we're to the point where full correct program synthesis is exactly tractable, but I think tools that are in this space can help us cover a lot of ground really quickly. For my own work, if I'm writing a small tool for something, I'll often scaffold out the first, the initial skeleton of it. So that's that. Let me know if you're interested in hacking them. Any questions?
Are you gonna put this up online so I can use it?
Yeah, running localhost right now. Yeah, I'll have it up by tonight.
Okay.
But it's super easy to run locally too.
Yeah, please send a website. I think tons of people want to use small dev, but are put off by the slight inconvenience of
Sure, yeah.
installation.
Yeah. Basic idea is make it more accessible, but also like I've like crafted a command line workflow with it where I like go delete a file and save something, but I think having a web-based thing could be really helpful.
Sorry, is there any existing web-based code-based generator? I don't know of any.
I don't know. Maybe I should have checked before I wrote this. I don't know.
Have you heard of E2B? So they have like a kind of an on-demand containerization service for agents.
Yeah.
And I think they're hosting small dev. Or actually, they are hosting small dev. It has a very similar UI.
Okay.
So, yeah, let's check that out.
Yeah, we'll do. I've been watching the E2B project. Cool. Other questions? Okay, here this time concurrent generation of files.
So what are like the common failure modes of small diff, and what is it really good at?
Well, I mean, the most common failure mode is just that the resulting file don't compile or work. I mean, and that largely depends on the quality of the initial prompt. So as you continue prompting, and actually I actually scaffolded this effort out with the kind of CLI version of small dev Go, and you can see what the prompt I was using. And I actually ended up in here like verbatim GraphQL schema. So it really depends on what you put in your prompt. That's the biggest thing. The techniques that we employ I copied from Swix that is employed to compute like the dependencies between different concepts in the files. I think there's a lot of opportunity to iterate on that. It's pretty naive right now. So yeah, I still find it very, very useful for at least getting the structure of a project down.
Maybe small dev handles this, but what is the output of the prompt? Is it just text, or is it like a JSON function call?
Well, so it's made up of, it's a series of prompts that make up how small dev works. The first, for me, my implementation here, I'm outputting JSON for the intermediate steps, the like file planning, and then the internal dependency step, and then the last generation for the actual file contents is just straight contents to disk.
How do you, like, if the AI responds with like something you don't expect, do you parse it out, or like, how do you do that stuff?
Probably should. No, it's just basic prompt engineering to try to discourage it not to. A big iteration of this would be to add function calling to get more structured out of it.
Is there a like small dev, like GPT engineer style code-based generator that does code interpreter style feedback and iteration?
I would love to build that. I'm not familiar with one. In my workflow, I often will take the output of this and then feed it back in, and like even pasting errors into the prompt so it avoids it. So not that I'm aware of. I feel like with some effort, I think you could iterate on something like this.
Yeah, probably huge.
The function calling actually produces worse code, unfortunately.
Oh, that's really
have figured that out. So it might be something to watch out for.
Very good to know that.
Yeah. There's a blog post.
Yeah, and honestly, like it's not that hard to encourage GPT-4 to give you code.
Anything else? All right, let's hear it. Great, thank you, SDGui. All right, we give you GPT Data Dictionary. That's right.
So nothing fancy, just something very, very practical. So who here has dealt with data dictionaries or ingesting data from outside data vendors? Yeah, one of the major pain point is you don't know what the heck is in those data, and your data pipelines break every other hour, or you reach out to their Salesforce and they have to go talk to their tech and get you whatever that's actually in the data. So data dictionary solves that problem. And so right here the goal is to use GPT to generate a data dictionary to help either your clients or your Salesforce to ingest the data. So a data dictionary is basically a metadata file that describes every single column and a human readable name and generates a description and then some sort of parameters like max, mean. So the other side of your data consumer can easily generate and ingest the file so they know how to use it. And let me go to the notebook as a quick demo. So it's, the concept is fairly simple. So we just take, because I believe, I don't know, but I will try. I think there's not GPT read enough data from different websites, so it knows how to translate a random variable name into a human readable variable name and then generate a description for that variable. So that's what we're using here. And right here, so basically we just run the library and run the ingestion, and it outputs, this is the Titanic data set I got from Kaggle. So it was nothing, so originally it was just passenger ID, survive, P-class, name, etc., and everything to the right is somewhat generated. The allowed values are generated by using pandas, just with different counting, but the data type is inferred, the variable name, it's human. We created a readable variable name so people can understand what that variable is and some sort of description. The description is kind of iffy, but it will be more useful if we can fine-tune a model based on an enterprise data dictionaries that's existing. So that's, for example, if you get data from some of the credit providers like Expedient or TransUnion, it's usually like, I don't know, 6,000 variables, and all the names are pretty much the same. Right. So this is the problem that this solves. And for the long work is set up some sort of auto-training, auto-fine-tuning to generate a more descriptive name and better inferencing for the data type, so the other side can source. Any questions? Awesome.
Yeah, this could be a really big deal. So this looks huge. Certainly as an intermediate step to automated data analysis, right? But I guess I wonder, like things like allowed values or data type, like these things certainly can be generated without a generative model. Do you see this as just like a good idea as a general metadata generation system? And how much value do you think things like definition of the variable and I guess like other linguistic summary stats will add to your data pipelines versus, like you can imagine building this app is just like a lot of automated metadata generation.
Right. So it's two separate things, right? So allow variable and data types, those can be auto-generated using pandas or whatever existing resources that we have. So this is that path, but the definition of data and what data type you sort of have to somewhat infer, because sometimes you just don't know. But like the allow variables, those ranges can be easily calculated using code. But the definition of variables and the readable variable name, those tend to be highly domain specific. So it will require fine-tuned models, and it's just a quick, easy and dirty way, at least for now, to generate a data dictionary so you can share the data somewhere, let's say on OSF or with your clients or potential partners.
More comments?
So what's the step function above, like, okay, so like Spark and Pandas have like built-in data inferences, like you can just feed a column and say what's the data type and even like, value counts. So like what's like the big picture add?
Right. So the big picture is on the engineering side, there's not that big of a problem for us to do this type of stuff. But imagine your product person talking to your salesperson, communicating with the product and sales on the other side, and so like there's usually a huge gap between us, engineer on one company, versus the engineer on the other company that's that needs to ingest the data. So the communication, there's at least 3 layers or 4 layers of different product and salespeople. And they are not going to use Pandas. They are not going to use GPT. They are Excel and CSV-based framework, right? So CSV, Excel, that's the basic data fabric of the internet, or at least for the enterprise. So this helps that process. Yeah, and once they get the data dictionary, they might be able to use it. And I think a lot of times when you do data exchange with certain more legacy companies, it's not going to be based in Parquet or any sort of fancy data engineering frameworks.
Any more questions for data? That's right. The research paper, a classic, centuries-year-old technology that has survived the modern era. This paper is called Algorithms for Boolean Matrix Factorization using Integer Programming. And this is an operations research paper based on a code base. What I have about today is a system that goes from a code base to a research paper. And a number of you have submitted to me your code bases. And so I am going to present research papers generated during this hackathon. So Han actually, you can see him here in the Slack. He actually had a big reaction. He said, so you create a Pandas AI paper. That's amazing. Ha 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 ha. Okay, let's see what he's looking at. This is from a code base. So he has this Pandas AI code base from G. Venturi. And if we take a quick look at this GitHub, Please hurry up. Okay. You have to take for granted that there is in fact a Pandas AI GitHub. Yeah, it seems like it's that. I'll just open this in. Okay, so yeah, basically conversational data frames, making data analysis accessible through natural language process. I'll give you a quick skim, the introduction, the related work, the approach, smart data frame, a conversational interface for data frames, implementation details, the smart data frame class, utilizing a fine-tuned GPT-3 model, caching, customizable prompts, middleware hooks, code base architecture, limitations, integration with language models, evaluation, efficiency of code generation and expertise, user experience, participants' ratings from 1 to 5, their evaluation, discussion, conclusion, acknowledgements, and an elaborate section of references. All for this Pandas AI database. So Pandas AI is a Python library that adds generative AI capabilities to Pandas, the popular data analysis manipulation tool. And so yeah, I guess what we did is recursively traversed this entire code base. We pulled out every single file of a particular subset of types. So, basically, I have a code base prompt. The prompt says code base code. So Claude really loves these like XML tags. And then I inject the code base with this %s, and then I end code base code. And I say extract all of the interesting information and novel insights from this code base and summarize them in the abstract of a high-quality research paper written based on the code base. And I enter the compiled string. And Claude pumps back to me, here's a possible abstract for a research paper based on the provided code base. Developing conversational data frames and exploratory code base. Data frames in Python, such as pandas and polders, have become essential tools for data analysis. However, creating data frames, blah, 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 blah. Notable implementation details, modular design, automatic code correction, retry and execution errors, multi-data frame support, smart data lake aggregation, configurable caching, logging, visualization, etc. All of this from the raw code of that code base. And then I write a ton of code that generates a research paper procedurally based on the code base in question. and I pump it through a LaTeX generator, and I run PDF LaTeX, and out pops a research paper. So this is the paper written super, super long. And yeah, eventually we just write to a text file, which gets compiled into a PDF, which gets sent to you in like 3 minutes. I present Codebase paper. Woo! So yeah, there are 2 people in the crowd who are some customers. I wonder, are they happy customers? Would you like to say something about your papers? Yes.
It's better than the one we wrote, so yeah.
Say it louder.
It's much better than the one we wrote.
Much better than the one they wrote. Okay. And yeah, I guess Han, you around. Repeat it out. Cool. So yeah, some happy customers. The part that I was really the code-based processing, and I had some paper gen code from strings. So the idea is code-based to description to research paper. And so, yeah, we'll put it up online. So if you ever want to write a research paper based on every hackathon project you've ever had, you can pump out every single research paper, put your name on all of them, and be one of the most prolific authors ever. Questions?
Yeah, what's going on in the code-based analysis? So like you said code-based to description. Are you actually looking at like the files themselves, or what are you kind of taking from the code-based?
Everything. Okay. Yeah, I am
just watch out at all.
Yeah. So to be super clear,
you gotta love Claude.
Yeah, exactly. Yeah, we grab the full text of every Python file, every JavaScript file, every C++ file, and put it in what's called compile string. And I can even show you a print. Do you want to see a printout?
Sure.
So, code-based prompt. This is what Claude sees.
Wow.
Oh, I'm short. Yeah.
Code's not long, yeah.
Yeah, but basically, yeah, it sees every function, all the params. Yeah. And this is just a recursive traversal of the directory structure with file extension choices. And yeah, it actually just uses file read.
If you were to take it further, like, how do you evaluate good paper from Codebase? Or like, what would be the next steps you would want to see from you?
Yeah, honestly, I think the cool thing that I wanted to do that I didn't, hey guys, if you could stop. The really cool thing that I wanted to do that I didn't is execute the code. So yeah, I guess I feel kind of bad. So it's CodeGen, and this is like vaguely CodeGen adjacent, but I didn't actually get anything done with that. What I should have done was run the code in an environment from the code base and used the output of the code with a variation on the inputs that is also generated in a kind of sort of like stochastic generation methodology to see what the outputs of the code base are for various inputs, and then use the input-output sets to write the paper. And then generate evaluation metrics, and then create evaluation code for the code base, and then use that evaluation in the paper instead of hallucinating results, which is basically what I think is happening. Yeah, that's what I do.
Are you generating graphs?
I can generate graphs, but I'm currently not. So there's a code interpreter API. Yeah, Jesse did this brought a PhD actually a few hackathons ago. Yeah, there's no reason not to do like code interpreter style analysis of the outputs of the code. It's just I'm not running the code right now, and so I'm not generating a data set with which to generate graphs. And so, yeah, it's not there. Cool. I think that's my time. Thank you.
Okay, so I just want to start off by saying that we didn't have the idea or any of the code before this hackathon, so not throwing any shade, but we should be judged accordingly. Yeah, it's not a 3 months old. Cool. So the problem statement is that, like, you know, everyone and their mom is running some kind of RAG where you retrieve some context, and you, based on the context, you use it to answer the questions. And a lot of the time, the data source has tabular data, and data got jumbled up, and it takes the data from the wrong row and wrong columns, and then it output the answer, very credible sounding answer. So what we wanted to do is to build a hallucination detection where we still answer you with the question that you asked, but also hit other open source models and cross-check the answers, and then flag it up to you if the answers don't agree with each other. Right. So Kitan's built an UI that she can talk more about.
So I guess one example is like, so this is just like, because we kind of think it's just a mock example, but like let's say we ask like when was George Washington born? So like in this case, if it's hallucinating and it's not like interpreting the contextual data correctly, we run like I guess several outputs across different LLM models and then compare the outputs across each other. And if it's inconsistent with the response, we flag hallucination and show the alternate responses that other models might have. So it's kind of like doing like a consensus check across different models. But then like if it's a question like, and like, if the answer is correct, then we don't need to show any other options. But yeah, so that's just like a quick, I guess, UX, UI process of what we envision it to be.
So yeah, I worked on the sort of like truth detection LLM algorithm, and basically the idea behind it was to try to use an LLM as a very localized cognitive reasoning agent where it's restricted to the information in the prompt or context that has been retrieved from an external database, and you want to verify whether an answer generated probably by another LLM or maybe human is correct or not. Ideally, it's not actually using any information embedded in the weights. It's only using the local information that it extracted from, because that's what it can directly verify. And so I did this with basically just prompt engineering, asking it, given a question and an answer maybe generated by some other LLM, is this true or not? And I was able to coax it reasonably well for certain use cases. It's actually a lot better when a human is making up some random answer that doesn't make sense rather than an LLM, because a lot of times the LLM will put in a lot of true information along with false stuff. So that was unfortunate, but you can see, for example, we fed it the attention is all you need paper and started asking questions. Some of them were things that were not contained in the information, like, am I wearing blue pants? With an answer of yes, obviously it's a hallucination, that's what's expected. In this case, the LLM was able to determine that it was in fact a hallucination. Another example is a specific blue score, which is correct, so it's 28.4 in the paper. That is not a hallucination, and these are basically a set of test cases that we checked. So we had maybe 10 different ones. Who's the first author? AGI House, unfortunately. Oh, actually got that right. So hallucination answer was true. The first author of the attention is all you need paper is in fact not the AGI House. And yeah, so who is the uncle of the first author? It got this wrong. This is a case where it did pull out the correct first author, so I think that's where it's getting confused. But here the response was, this is not hallucination, when in fact it should have no idea who the uncle of the first author is. It could be that somehow the LLM actually knows that. I don't know if this is really an incorrect fact, so maybe someone can verify that on Google, I don't know. Ash Vasari. Yeah. So. Any questions? Yeah.
Can you show your prompts for determining the consistency checks? Because I presume like your LLMs all output different text of different length, and you have another LLM that compares them and says these are the same or these are different.
So this is not. This is just for one specific output of an LLM. So it takes context, question, and answer, and it outputs whether it's a hallucination or not. So basically a Boolean. So this is the prompt.
In the URL, and then it will just keep growing in the number of models that it's crushing. Any other question?
Yeah. Which types of questions can you ask it, which it will hallucinate, and then it will also not know what it hallucinated? Like, have you thought about this? Is there like a certain type of question where it would just be, it would hallucinate upon trying to know if it hallucinated?
Yeah, I guess if you ask the questions and then it try to answer, and if all the models also answer incorrectly,
yeah,
then that's like a super niche edge. Like, you know, like if you ask GPT 3.5 and then all across the board, Llama and Falcon and everybody agreed, like also have come up with hallucination answer.
They're all pretty like different on little math riddles. So if you say like there were like 3 apples, then we got like twice as many and we gave away half of them, how many apples are left? Every model will give a different answer. And like some might be right, but that's kind of for the case.
Yeah, so like we rank them, right? So similarity score, we rank for each of them. So the first one get 100 and then 90, 95, and then we'll just like, you know, show that to the user. So the user can sort of determine the thresholds. Like, okay, if it's above 60%, I need to double check it. Versus if they all agree, like in this case, then we're good. Cool, thank you guys for your time.
Thank you.
Okay. Who's heard of HumanHuman? Yep. GPT-4, 80%.
Presentation.
Llama 2, fine-tunes, catching up, or reading them. Who thought that humans had something to do with human eval benchmarking at first? Maybe? Okay, we'll get to that. So the first thing is that you probably want to get familiar with this if you are doing CodeGen, but unfortunately the repo just throws you one big tar file. So the first thing I did was just put this up so that you can actually just look at what's in there, because it looks pretty interesting at first, but you kind of look at some of the examples, which still probably are valid, but they're a little esoteric, I guess, in their application to real coding. So that's the first part. I think everyone should go and try to check these out to see what we're climbing towards. Is this AGI or not? Probably not. And then the second thing is that actually after this I was like, what can we do with this? So I started a game. So who wants to play against GPT-4 in coding? Who volunteers?
I'll do it.
Okay, come up.
I love HumanHuman.
All right.
That's
oh, okay. Well, yeah, you can have a head start. That's okay. All right. So, do you have a task that you prefer?
I know the ones like the first 20 tend to be easier. So
okay, let's go.
Oh, I can pick any. Okay, one. Okay. Check. This is my job interview. Are any two numbers closer to each other than given threshold? Okay.
So GPT has already passed, and that was handicap. But we'll let the human keep going.
Oh, okay, for sure. So now we're doing Python. So I can just say pass. Wait, so it passes in a list of numbers and then a threshold. Oh, okay, for sure. So I'm just gonna do like the most computationally expensive way to do it, which is just 4.
Wow! Look at that.
That's really my
sorry, it executes on save, so I should have mentioned that at the beginning.
Your assumption failed.
Yeah.
So GPT-1 in this one. You want to have another go?
I mean,
another problem. That's one of the easier ones. So I mean, someone else could try it.
It's on GitHub if you want to try it. Basically, it'd be super interesting if we got people together and actually had a human benchmark for this, because I don't see it anywhere. I'm guessing we would all hit probably like 40% at best, and that's including the use of backspace, which GPT doesn't get to do. It's also going to be difficult to do with all the autocompletes already out there, so you kind of have to like isolate the environment.
So you're telling me our eval benchmark is totally generated by models?
Sorry?
The human eval benchmark is totally generated.
No, it's curated by humans. That's the human part.
Curated. Okay.
But we don't have like a human level, right? We don't know at what percentage humans actually perform it.
I see.
Yeah. So that was the idea.
Cool.
Have you considered a white paper analyzing the unpacked repo?
We'll spin it up now.
You're saying we should use Codebase the paper to generate a research paper on.
We'll use Jeremy's thing.
Yeah. Well, it's your thing. Yeah, this reminds me of the game for labeling image data that Google had put out, where you would compete. I don't know if any of you played this back in like the 2000s. You'd compete against someone else to come up with the right label for images that were ambiguous. And yeah, I think Google created a massive capture data set that way. So it seems like it could be actually like fun, like market it to college kids doing like internship applications or whatever. And,
sure, we can get free data.
Yeah, free data, exactly.
Publish.
So I guess in the actually evaluating human ability to code, it sort of seems to me like an intelligent human would lose to GPT-4 on these simple tasks, but they beat GPT-4 on like super complicated tasks that require like thousands of lines of code. And even foregoing the whole context limit constraint, there's still situations where like you have a high degree of cognitive load, and no matter what prompt engineering you do to GPT-4, it's going to fail to do those kinds of tasks. So, like, I don't know, while you were building the project, did you think about those more like serious kind of like evaluation difficulties when it comes to code generation?
Evaluation difficulties, as in like, is human eval insufficient for real world use cases?
Yeah, in the sense that like simple, like ironically, like. Or I guess not ironically, like GPT-4 beats out humans on simple things, but it loses out to humans on like really complicated things.
Yeah, I mean, I think that's why I'm trying to get people to look at it, because if we're climbing towards this, that's not good.
Yeah.
So I'd love to see examples like that, where you're doing like maybe mundane but real world tasks that are long and complex, at least in scope, but like not algorithmically complex.
Yeah.
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 I don't know, I feel kind of, I don't know, I'm going to just come off as like stupid and asking the question too. But in the case of like how you've structured it here, right, where it's like GPT-4 is now like the like quote unquote like ground truth, and the human, it's like seeing if the human can measure up against it. But then if you kind of like flip to like what the normal case is of like the human's answering it, and then GPT-4 matches the human, then it's good or not. Isn't it like a lot of just like kind of like inverting the metric at different points then, or is there kind of like a secondary like benchmark for like kind of like compare which one is the real ground truth?
Yeah, that's a good question. So it's just like humans used to be ground truth, right?
Yeah.
But now we're inverting it so that GPT-4 is closer to real. I'm very jealous of people that work in CodeGen. I'm doing evals for random like LLM generations, if you want to talk about that. But for CodeGen, there's a real truth, right? Does it compile and does it pass the test cases? So I think in that case we can get away with a lot cooler things than just human ground truth and human imitation. So good for them.
Give it up for human eval.
Alrighty, good evening, hackers. How are we all doing today? That's a decent response for about 9:30 in the evening after a long day of coding. So, who here has ever tried to convert a file and decided that that was really fucking painful? I shouldn't have sworn. I'm really painful. there's at least a few hands. And who's especially used FFmpeg and found that to be really painful? Yeah, pretty much everyone here. What if you could just natural language talk to this thing and get it to write some code and run that code and do the thing you want to do with your file? So build a little UI and you can throw in videos. I already clicked one earlier. So and let's say we want to split this video into chunks and we say do it. Oh no. Let's refresh and see if that'll fix things.
The joy of life business.
Oh, no error this time. Magic is in progress. So what this is doing, this is running a little React agent. So doing things like FFprobe to work out the length of the video and then trying to chunk up the video and I think it's actually output the thing. And so we'll see, it generates something and like most humans, it really didn't work. So it's generated something where I'm not even quite sure what it's done, but we can just tell it. We can be like, no.
This is awesome.
And what you'll see is that it then feeds. So what it feeds there is it will feed the prompt that the FFmpeg command that it previously ran, and it will feed that back into basically the same process. And now it's, I guess.
Are you generating the UI?
No, so for now the UI is static. The UI we've created. There is an idea. So the whole project started to be very generic. Started to be like, let's do conversion for anything. We're going to have socks. We're going to have image magic. We're going to have FFmpeg. We're going to be able to cache these skills and generate UI components for, if you want to say trim a clip, it would work out that you don't just want to trim it like one time after the first 30 seconds. You want to store that skill with an arbitrary like slider for where you want to trim that clip, and that would be cool. Not sure we can really see what's going on here. Still running. Good thing, here's one I made earlier. And it has actually worked, and it chunked them up in 10 seconds. And we can see... Oh, interesting. Oh, actually, I had never played the video. Oh, it is a video. I was concerned there that we might have... There we go. So, it works. And I did it on another one as well. Tried to split this video in half into two equal chunks, and it did it. And you can go, yes, it worked. And, oh, no, wait. We go here and go, yes, it worked. And there's confetti, because everything's better with confetti. Any questions?
Is this like LangChain?
No, this is
your outputs look LangChain-esque though.
LMQL. I don't know who's played with LMQL. It's for me, it's just way better. There we go. So I've just defined this little agent. So what you get with LMQL is more like a declarative style of prompting, and so you get to not worry about how do you parse outputs. You can have kind of multiple outputs in your generation. You can interlace code and language models all in this nice sort of single file. And I mean, we were intending to have a bunch of different prompts, which would be a bunch of different LMQL scripts, and that do a bunch of things like suggesting potential previous things you've run to run again. And, but yeah, this is just the one thing, and it's basically a prompt that gets it to run in a React-style agent format, and then you kind of force it to kind of follow these steps. So it can't hallucinate and go wrong, or can't like, get distracted. It just does what it's meant to do, and it gets the errors and fixes the errors and things.
That's
another one at the back.
I remember when I talked to you earlier today, you were mentioning something about like pulling stuff from the docs and like doing some RAG there, because out of the box GPT-4 isn't great at FFmpeg. Yeah, like, were there any quirks or interesting things there?
Yeah, so didn't end up really going deep into doing this kind of retrieval-based generation, but it is sort of doing that, because we kind of, I mean, we pre-prompt with the FFmpeg-h, we like just put that in the prompt, and then we tell it that it maybe should try using -h occasionally for like the sub-tasks. And I haven't watched it running enough because it's not that exciting. It's like watching paint dry. I'm sure people will get bored of watching their agents run. It's like kids growing up, but yeah.
Can we get an audience demo request?
Yeah, well, yeah. Anyone want to request something to do with the videos?
Make a GIF.
Make a GIF. Okay, well, let's turn Big Butt Bunny, one of the OG classics.
Make this a GIF.
Do it. See what happens. Oh, it's not going to render the output though, because it only renders video output. So we'll see what appears in the folder. It's probably going to show a little React error or something, or whilst that runs, should we? Any other questions? And hopefully that'll distract from the output not working. Alex.
So you can also upload video to Code Interpreter, or Advanced Data Analysis, and it seems to do a pretty decent job. So what would you say is like kind of the key difference?
Yes. So I think a bunch of times when you want to do conversions, you end up going to the like PNG to JPEG.com or whatever, or like you can use Code Interpreter to do these things, but you really don't want to upload tens of gigs of data to Code Interpreter. I think the limit is as well maybe 50 megabytes. Like, I haven't played with it for a while, but that's the big thing. You want to be running these things locally. You don't want to have to download some heavyweight iMovie equivalent just to trim your clip or turn it into a GIF. And you also don't want to have to upload it to a website. And see. Okay. Whilst we change over, I'll see if the output's there. Output.gif.
Haden from the camera.
Whoa.
Thank you, ChatGPT.
Thank you, Video Wizard. One last round of applause.
So I did like a bit of an exploration around doing retrieval augmented generation for API docs. So I figured like GPT-4 is pretty good with popular libraries, but then if you have like some newer ones that had some changes, there's a lot of times like new functions there, or some function headers have changed. So I did a bit more of an exploration around how you can like store this and then later do generation from it. So like one of the examples I used was HNSWlib, since there's like a fair bit of new functionality there that's not in the training set for GPT-4. So here's like sort of the original structure, some of the README for it. So it gives like some description. So I did kind of a simplified version of that to generate a structure of what the function headers and stuff look like. So that way we can get more reliable generation from it. And I did a bit of augmentation upon that for searching through the different functions to find sort of more relevant ones for what the user is currently doing. And then to try to find the functionality of what someone's looking for in a library, like even if it's after the training cutoff. I can't really show it right now, unfortunately. But yeah, you can ask it questions and compare with and without RAG for given libraries. So I want to expand this to read the docs. I worked a little bit with their API earlier. Since there's like hundreds or I think a few 100,000 different projects in there. Since there's like a standardized format, working more towards like pulling in a variety of libraries and doing auto detection from Python scripts.
Any questions for API Oracle?
Does this work for like other languages too, or like I guess this is for Python and specific like types of things to do with Python, but like can you apply this to like other?
Yeah. So you can use C++ just fine as well. If you're pulling from the docs.
So just that I understand correctly, so you do regular RAG, and you're searching this list of JSON objects by string or by vector.
So just initially like making the model aware of what functions are available for description, and then from there having it pick from the user.
Oh, so you're doing like a multiple step approach.
Yeah.
Where you give it all the available functions, then it asks for more information, and then you give it back that, and then it comes up with the.
Yeah.
Cool. Interesting. How hard would it be to add and read the docs? Do the whole thing?
The chunk of the day was spent looking for the read the docs API. So they.
Hi, I'm Vivek. I work at Common.ai and I plot a lot of plots, and I still don't know how to plot things. This is a day of my life. I just want to plot things. I know what I want. I don't want to memorize the really complicated plotting APIs, and I don't want to have like 5 different documentations open so that just I can plot things. So this was like an effort to do that. So I just wrote like a small app where you can. So I just started this, ran the script with this file. So I have these columns. So I'm just gonna say some things here. So it plotted this. The view is all screwed up. But basically, so the x-axis became log.
Whoa.
Yeah, so this looks good. Yeah, looks good. And then now you can, I mean, it gives you the code of each step, so you can like paste it to wherever you want, or you can just like download this plot. I mean, the actual view is side by side. I think it got screwed up with the projector, but the idea is that you have like a working thing, and then you have an iterative way in which you can keep modifying that thing. So I know that Code Interpreter has like something like this where if you upload like a CSV, you can plot things, but I really don't like that. You just keep scrolling. Like I think Jupyter Lab had the right idea that what you want to work on probably is like, especially with plots, it's static, it's there, and then you can keep augmenting it by like doing different things. So that's pretty cool. So yeah, this is my project.
How many countries we can name from that chart? How much of a rest?
I think this is like.
I can name 3. I think.
This is probably China. This is probably India, I guess.
Can we have the label for also?
I don't know. We can try. Okay. Oh yeah. Nice. That's United States. This is China. Oh wow. This is Japan. Yeah, this would have taken me to, this would have required me to, open that page, look at what the documentation is, and then do it. So yeah, this should be much simpler than what it is right now, and especially the next step, which is like, okay, this is good, and especially if you connect it to a database, this is good, and now you just want to track this over time. It's unreasonably hard to do this right now, which is to just write some metrics and just track it over time, and then just like spit out an app that can do that is just super hard. Hopefully some tools like these can make that process simpler.
Are you gonna release it?
Yeah, it's on GitHub, so you can just already run this.
You do it right now.
Yeah, so it's just a script. You run it with like a CSV file, and then you can just keep chatting with your plot. Yeah.
Can you modify the CSV data before sending it into the plot, or is it exclusively just plot generation?
I mean, this is exclusively plot generation, but you can just open it up somewhere else, and then you can modify it.
Gotcha.
This is just,
Yeah, I didn't know if you could like aggregate things prior to sending it into the plot.
Yeah, I mean, I'm pretty sure you can do that here as well. I mean, it's evaluating some snippets, so you can like add stuff, but it's as is, you can't do that. But it shouldn't be too hard to like add some aggregation steps and then plot it. That shouldn't be too hard.
So it looks like you did this with 150 lines of code.
Yeah.
Can you just show us all the interesting parts of that code?
I mean, it's actually pretty simple. I mean, I just started this like a few hours ago. Let's see. Yeah, there's just an app. I'm using Dash. The Dash is this. It's like a framework by Plotly to create data apps. It's pretty simple. It's pretty nice. So you can like, with Python, you can like create all these HTML elements, which is pretty neat. So there's no JavaScript in this whole app. It's all just like using Dash to create HTML elements, and then so these are my prompts, and then so when you get a message, I'm just putting it in. When you get like a new message, I just put it in, and then send the entire list. And it gives me a snippet that I just eval, and then I display it again using some Dash HTML. Dash is pretty cool. I mean, we use this at work for like a lot of data apps. It's very neat. I don't like writing JavaScript. It's very nice to just write Python and then generate like reports and metrics that you want to track over time, and it creates a neat like a neat application. So I'm really hopeful. I mean, I was hoping that something like this would already exist. I think Julius is something I saw while researching today. I came here and then I started looking if anybody does this. So there is something, but I really like the idea that you have your working thing, and then you have something that to like keep iteratively augmenting your working thing, which is like a data set or a plot or something, and then you don't have to scroll over, you don't have to do any of that. That's pretty neat. So yeah, you guys, anybody can, if you have any data sets you want to visualize, you can try it out.
Yeah, I just want to comment. I think this is kind of like state of the art for a lot of people who have real databases that are really big and have no API, where you can hook this up.
Yeah, no, exactly. Yeah. I mean, I tried doing it with like an SQL database. I ran out of time, but it should be pretty simple to like hook it up to a database and then do all this stuff.
Yeah, good stuff.
So, yeah, as I mentioned this morning, I'm working on code generation for automating web interaction workflows. So Voyager is this whole framework where you use an LLM to generate small functions that compose together in a hierarchical way to accomplish a much more complicated web, any type of task. So rather than your agent interacting directly with the environment, your LLM generates code that then performs those web interactions. So the specific use case we were interested in is looking at the startups that a VC has invested in. Every VC has like a different portfolio website, and we were actually running into a lot of VCs sending outbound to us when they had invested in competitors, like direct competitors, which was quite annoying. So we wanted to start like automating the vetting process for that VC inbound. So I'm just going to run this real quick. There's a pretty simple prompt But also, you notice I define these inputs as well as the outputs that I want from the as well as the output that I want from the code that is generated. This code generation is going to happen a lot faster than you'd expect because we're using Helicone, so this is all cached. So yeah, it loads up the NEA website, and then it generates the code, and it starts navigating through the website over here to find interactable elements, clicks over to the portfolio, and then it fails to actually find the list of portfolio companies. Like it'll output like an empty list in a second, but yeah, there it is, it's empty list. So it failed to parse the website effectively, but it was able to do the web navigations. And if we want to look at the actual code that it generated, let me just pull this up right over here. I'll just grab this and paste it over here so you can like take a look at the code that was generated. So in terms of the way that we actually do this is I first have it generate this main function where it implements, it like uses unimplemented functions, like it strings together these unimplemented functions, and then we go in for a second pass to implement those in those functions themselves. So first it writes this main function, says like, let's find the investments URL first. So in order to do that, we need to navigate to the investments page, and then it needs to extract the investment data and then parse it into an investment list, which is like a pretty good like high level of the hierarchy overview of the tasks that are supposed to be completed. Then we take those unimplemented functions and we feed them into an LLM a second time to implement them. So for example, for this like navigate to investment page thing, it does all of this, like this is all generated code. And one interesting thing here, actually I think one of the most insightful outcomes of this project for me has been this intuitive find tool. What a lot of people doing web interaction, so this is the Web Arena paper, what a lot of people do is take the actual HTML or like a accessibility tree and they feed it into an LLM to get some output, to perform some action. But what I decided to do instead is to perform retrieval augmented generation over the tags themselves. Fuck, it's over here. It's, oh, whoops, well, there's a wrapper, but like, yeah. So it's a pretty hefty kind of thing, but like the general idea is, yeah, we're just doing this retrieval augmented generation over the HTML itself. My timer hasn't gone off yet, but maybe, I don't know. But yeah, all right, questions? Yes.
I'd love to go into more detail about how that works, because I think, yeah, navigating websites is one of those kind of current unsolved problems in agents that will really unlock more value.
Yeah, I mean, so the intuitive find function, like again, pretty straightforward. So first we embed, we have this embedding service that it's just a wrapper. We have the embedding of the target element, right? So that basically just means like the text that the model will generate. So like we saw over here, it's like investments or portfolio link. It uses it in a couple of other places too, I think. Or okay, this time it only used intuitive find once. But yeah, so we embed the element. We embed every single tag in the page. But like we can, but actually sometimes we might want to filter by only interactable elements, right? So only the search bars or text inputs or links. So we add this flag, and actually over here you can sort of see like one of the skill, like we pass a skill to it, this intuitive find skill, and one of the flags over here, one of the arguments over here is like interactable elements only. So it can decide whether it wants to filter over those interactable elements. And then yeah, once we embed all of those, we just run cosine similarity, we find the top k, and then we convert that top tag into a Selenium object, because all of this is happening in Beautiful Soup. That's also like another crazy kind of function. I spent a lot of time navigating the deep, dark depths of XPath and Selenium internals. But yeah, so yeah, you convert it to Selenium and then you feed it back to the model and then it can do whatever it wants with it later. Yeah. Yes?
So I saw that you were planning once at the beginning of the VC page. Is there a downside to replanning after each click or a few clicks?
Like reloading?
Like writing code again after seeing new web pages? seeing new HTML?
No, so actually the model has zero access to the actual HTML of the page right now. So it is a very strong ideological kind of take, right? So like everyone that does web interaction is doing stuff like this where they're feeding the HTML to the model. But sort of my take is that HTML is crazy, even humans can't deal with it, so how can you expect these models to be able to handle it effectively?
You said you're doing RAG, so why not do RAG at the next?
RAG at a higher level?
No, click and then RAG and then click and then RAG.
Oh, that is what we're doing. So we're doing RAG only when the model makes a call to intuitive find, right? So that intuitive find function.
Or sorry, I meant click, write code, then RAG. Click,
oh, I see.
Sorry. It's very nuanced.
Potentially, yeah. I mean, I'll have to think about that longer. But the goal, I guess, is to create a piece of code that can be scaled across 1,000 websites and should be sort of agnostic to an individual website, more or less. And it should be able to capture those edge cases without having to rely on the individual website itself. So I've sort of tried to abstract away the necessity of dealing with a website's strangeness into that intuitive find function, but definitely there are cases that you can imagine where maybe you have to navigate through some other page, the fundamental structure of a site is different, and in that case, maybe you do need to be generating code based off of the site itself.
So are you caching that code?
Yes. So this all goes into a skill library over here. Yeah, there's some code for that. But yeah.
When you ask question about the nature of time, do you think it's time to revisit whether it's feasible to use regular expressions to parse HTML together with
I don't know. I'm certain there's some use cases in intuitive find where we could speed some stuff up with that, but yeah.
Yes. What was the actual hack that you invented this time?
Yeah, so I was actually adding a bunch. So in our core code base for our product, we use intuitive find very thoroughly. We use it for all kinds of stuff. So we've been spending a lot of time improving that function as well as the surrounding functions. So I've basically been pulling all of those improvements and pulling it back into WebVoyager right now. Yeah, that's what I spent today doing. Also trying to recruit some help to do the critic agent because I don't know, I'm sort of traumatized trying it once or twice because there's so much stuff to think about in that whole iteration loop. But hopefully the Vasek from E2B said he'd be interested, so we'll see what happens.
So you said that you were looking through the logs and it didn't pull the portfolio companies, and you had to do that manually. Have you ever thought I don't know, what sort of analytics along the way do you think would have been helpful for debugging?
I wish there was a tool to evaluate our agents, but unfortunately, I don't know. You'll have to come up with something for me.
Okay, memes aside though, what sort of flags do you think that when you were doing this, I wish I had this specifically to tell me that I was going wrong?
Yeah, so this is a really hard problem, I think. You can evaluate this end-to-end performance, right? You have this huge task of find the portfolio companies, but now we're generating all these smaller functions along the way. How do we write unit tests for those individual functions to ensure that generated code is correct? I think that's a super hard task, and maybe there's a way that we could auto-generate tests and it works, but I think that would help performance a lot, even from a critic agent perspective, because if we can get useful criticism, useful feedback from the environment on what went wrong, then the code generation performance will improve significantly as well. Yes, last question.
Yeah, question about web scraping. Websites I've also done a few website scraping things, so interesting problems. And every website's different. There's absolute positioning, all sorts of random things. And, WebGL maybe, and hard to interpret a better website. So is there maybe a different way to, I guess, transform the HTML to a different markup language and then use that to infer the information as opposed to just relying on the HTML structure itself?
So the Web Arena people actually do try something along these lines, but my senior thesis was actually on vision language stuff. So I've been trying some experiments with this. Like basically like feeding a screen. So the problem is like you feed. Marco was actually showing me some like GPT-4. Like he's like, look at this. It can do web interaction, and he was like, oh, like find the search bar, and it's like, oh, the search bar is over there. Blah blah blah. Whatever. But like you can tell, like GPT-4 can tell me like, oh, that's the search bar. Like I see it, and these are all the details about it. But that doesn't actually give me the ability to go and click on it. In order to click on it, you need to have like pixel values, and that's a lot harder. The like models aren't trained to understand where a pixel is in an image. So like I've been like playing around with fine-tuning models to like do this kind of like grid, like putting a grid on it, and then like basically fine-tuning it to be like, where's the search bar? And it should be like 1600, 900. But like they're terrible at it. Like I was fine-tuning Edifix 80. Actually, no. I was fine-tuning the smaller Edifix that came out last week or 2 weeks ago, and it's not doing too great. But yeah, I think HTML aside, like vision is the way humans interact with web pages. So ultimately, that's the way it should be that models do it too. Cool. I should probably find me after I've taken up a lot of time. Thank you, though.
So anyway, just recycling the project. So anyway, who remembers this viral meme that happened 2 days ago? So Smash for Pass AI, the idea was like you could use like a Tinder-like interface to basically improve your preferences. I'm gonna leave like how politically incorrect this is to the side, but kind of the general idea, which is like you have like dating apps which are like they're learning your preferences based on like how you're swiping on people. So I saw this tweet from Avi, and we were talking about this a long time ago, like, which is like, why is there like no easy way to like mood board, like kind of how you're feeling about like UI components? It's like really annoying. Like, I put out a tweet like a few weeks ago, like asking like, where's my logo designers out there? How do I make a logo? And like a bunch of people message me, and it's expensive and annoying, and it takes a lot of time. Like it takes a ton of time to just like design things, and we're trying to figure out how to make it faster. So anyway, let me just show you the product. So let's see here. So basically, this is the AI mood board. So I used GPT-4 and Cursor to just like generate a bunch of components like this. Like I did not write this. And let's just say like, oh, I like this. So yay, now it gets added to the mood board. And if I like this, oh, it's not so interesting. Dislike it. But I like this. Ooh, look how fun it is. I can click it and stuff. And the idea here is like, I've taken like all of these effects. Oops. That's kind of crazy. And we can kind of like save the tags. So if I'm a designer or a UI engineer, basically here's the kind of the things I do like and what I don't like about components I've generated. And I can kind of like generate like a UI component mood board. So that saves me from having to go to Model UI, ShadCDN, or AntDesign, and I can just like generate components on the fly and just catalog them for my front-end engineers. So that's MoodGen.
Can I work with real UIs? Like, can I plug in my website?
Well, I can just show you the code. So I wish I were generating them dynamically. I just kind of did it. Inputs 1.jsx. Oops, sorry. Buttons 1.jsx. Buttons 2. So the way I did this is I just like went to Cursor like at the sidebar. Like I wrote so much code today, but I didn't write any of it because like ChatGPT did. But so the prompt I used was let me see if I can find it. Let's see here, history. Yeah, so here's the prompt I gave it. Yeah, here we go. Okay. So create a drop-down styled component with the following guidelines. So we generated like a bunch of like different prompts for like different like style guidelines. Let me see if I can pull that up. Prompts.
Did you use AI to generate the prompts?
Yes. Sorry, so like minimalist, retro, bohemian, flat, dark mode, right? And then like basically kind of gives a high level explanation of what these things are supposed to be. And so I just like copy pasted them, like manually obviously, into ChatGPT, and I say, hey, create a component for this. And then here it is. I just copy pasted it into button 1.jsx, button 2.jsx, so on and so forth. And then like what the app does is it just like takes all of these components. I only did like buttons and drop downs because it's overkill otherwise. And then just like it renders them on the Tinder swiper thing. And then whether you like or dislike it, it goes on the mood board. And then your save tags go down here. So like it turns out I guess like we like box shadows and bright colors. So seems thematic. Any other questions? Who's next? Oh, another question?
Yeah. How does the feedback get feedback into like what is generated next?
I kind of wish I thought about that. It's just random. So I mean, the thing is like, so these are tags that are associated with like this component, and then like this section down here is like the set of all tags. So you have duplicates. I guess we could like add a counter, like things that are counted multiple times kind of get way heavier. Just didn't really get to that, if I'm gonna be totally honest. Yeah, there's like no feedback mechanism just yet. If anybody has an idea, like if anybody's worked at a dating app company, I'd actually really like to know the algorithm. Anyone who's like done this kind of stuff? Yeah.
First job was designer at a dating company. But, I didn't work on the code side, but yeah, there's some things. But I also work in design and working kind of in the space, so we should chat. I have a question. I guess what are you gonna add to this after? What's the next thing?
I think like maybe figuring out how to like show you more similar things to what you've liked. That'd probably be one thing. Maybe a paywall. I don't know.
Would you ever add images? Or like can you turn images into UI?
Oh, like generative art, or like this like Midjourney things where you like draw the component.
Like if you have like 20 screenshots, can you turn it into a UI library?
I think there's a Figma thing that does that. I mean, we sure don't, but that's an interesting idea, actually. Okay.
Yeah, what happens if you have a model evaluate like this, like, and just feedback until?
Oh yeah, that'd be really cool, right? Like, what if we take like all of these saved tags and say like, these are the components I like, and then we feed that to our prompt over here and just say like, the user likes bright colors, box shadow, retro, etc., etc. That would probably like generate more components similar. Oh yeah, that's actually a pretty clever idea. Yeah.
It's very complex interface.
Yeah. I think like probably the next step, like if we were to do this kind of like more deployable, is instead of like pre-generating all the components, is generate them on the fly, or like maybe have like a cache set of like original ones and then like generate new ones on the fly, and that would be pretty cool.
If you don't know me, I'm James. So unfortunately, this is a project that I have been working on for a while, but the good part is I actually shipped some big features today, and it is CodeGen related. I guess everyone here is pretty smart, so you're probably smart enough that you're not spending your time learning how to code in React. And that's what I've been working on. The front end of this is closed source, but I'm actually open sourcing all of the agents and prompts to it. So if you have any questions about that, feel free to ask me. So basically, the idea is it's a super fast way in your browser to create a React app, make some modifications using AI, and then ship it right away. So I'll just show exactly. This is the app. It's at gitwit.dev, and you literally so you have like a little React ID here. This is a React app that's being rendered. It's using something called Sandpack, and what that's doing is it's actually compiling the TypeScript, rendering the whole app in your browser, client side. So yeah, we can just do like you can just type in any kind of prompt that you want in this bar. So for example, like let's add a bar chart into this React app, and you'll see coding live. And yeah, we see here that a dependency was added that also got added automatically into the package.json, so you shouldn't normally have to worry about dependencies. Yeah, of course you can also edit any of this live as well in the editor. Yeah, maybe I could just show like a couple
things that I've done where it's been more like 5 or 6 prompts sequentially. So like, this is like a checkout, an interactive checkout React website. The whole thing was written with prompting, with maybe like 5 prompts. What else, for example? Like, oh yeah, here's just like a simple doodle. I did a couple prompts, and oh yeah, here's a slightly more complicated one where I take a CSV text box, render it as a table, and then you can also sort it. All of that was done with maybe like 5 prompts in here. What I did today was this sort of deploy feature. I came up with a super hacky way, but a way that works to sort of live deploy your apps. So yeah, you can really just go on right now to gateway.dev. You can make an app with AI, and then you can share it. You can make this shareable link, and then you can just share that React app with anyone, potentially not writing a single line of code.
So can you modify multiple files with the same prompt?
Oh
like
yeah.
If you have like if you have like 2 or 3 components that need to be modified to achieve a certain task, like can you, or is that
yeah, so can you modify multiple files? Like presumably in a React app, you'd want to have like components, hooks, probably spread up into different files. I've played around with this, and in the current version, I do not have that because actually I've been able to make like working apps just editing one file, and I want to test that like to its fullest. But yeah, the next step after this, one of the things that I'm really eager to do is basically to have this, so one thing that I do is I make components, and then I say, can you divide this into multiple React components? So I like to have it sort of automatically refactor, and then as you're making more components, it's like, why not put those into more files? And what I like about React is it has that hierarchical structure, which will make that easy to do. Yeah. Yeah.
In testing and playing around you've done with it so far, have you found that there are certain UIs or certain types of components that you tend to struggle with in terms of generating? Because, yeah, just that question. Like, are there certain things that are hard to do?
Definitely. And it's sort of just a matter of weeding those out. So like, I think like one example where I made a lot of progress very easily was with the charts. So like here I just gave an example of a chart. And I have not fed it any documentation, but I have watched for when the user, I've detected when the user is dealing with charts, and I've specified, don't use any of these chart libraries because I know that you'll get them wrong because your internal memory is wrong. So it's mostly just figuring out those paths and then avoiding the wrong paths.
So you just preempt it by modifying the prompt.
Yeah, and as I do more and more of that, I will eventually become an agent. Yeah. Yeah.
Sounds like maybe you might have answered it right there, but I was going to ask, are you doing any retrieval augmentation here? How do you deal with cutoff dates being old APIs?
Yeah, so right now I'm doing the laziest, like I'm hacking everything together and doing the fastest way to get it to work. And I think long term, RAG will be like a good way to get it to work. Right now, I can get a lot by just like injecting things, small things into the prompt. Because I find that for most React apps, like there's maybe like 20 libraries, like 20 of the most popular libraries, and so I can sort of prompt around that. But like one example of something that I'm struggling with now is like, for example, if you wanted to use the OpenAI API, like they just put out version 4 like a week ago, and the syntax is completely different. So retrieval augmented generation might actually be like the easiest way to do that. I don't know of an easier way. Yeah. Maybe like one shot prompting, for example. Yeah.
Can we try changing the style? Does that work?
Yeah, sure. Let me do like a smaller one so it takes so it goes faster. I'll just do like I'll just make here, and I'll just say like oh, here, I'll go back to this one. So sure, fine. Did I break it? Oh, here. Ooh. Can make a new project. Here, let's first add some Should I add some buttons? Or something? So add some buttons. We got 2 buttons. Yeah, this is good. What would you like to change?
Let's make it like retro style or something.
Make retro 80s.
Yeah.
80s style. So interesting. Yeah, I like this so far. It's okay. Yeah. Cool. Yeah, so like I said, I'm going to be open sourcing the prompts, and feel free to, it's free to use, and I just started like a Discord channel where I'll be putting like a bunch of examples, maybe like 1 new example every day of what you can build with it. Thanks.
So I took CodeGen like very literal, and we're gonna convert research papers directly to code. CodeGen, you know. So a little bit of background behind this. So I read papers like the more like recently like Voyager, Orca, and whatnot, and I was like, wow, this is actually a really cool concept. But stuff like Orca not exactly sharing their code, their models, and everything. Same with Voyager, it's pretty dense. I wanted to know how can you re-implement a lot of this. A few years ago, I'd read through a lot of papers. There was no ChatGPT, so you'd kind of struggle to actually like recreate a paper, see if it's valid. Am I messing up? Am I doing something wrong? Or what's kind of the process to actually implement a research paper? So I figured I would just try something out today and see how far can we get in a couple hours to see like, is it a viable solution? Are we there yet? So what's kind of happening is we're just gonna ingest in a full paper. We're gonna use Archives API, get all the paper context. So the title, the abstract, the first thing we're gonna do is summarize it so we have a summary of the paper. With that, we're gonna do a linear call to kind of outline what are the experiments of this paper. So this is textbooks is all you need if you've read it. So this step kind of really helps. You get the experiments kind of laid out step by step. So what they did for pre-training, fine-tuning, how to evaluate, so you kind of know what needs to be done to recreate it. And then the steps from here are pretty straightforward. Once you have the evaluations, you can create a sort of file structure. So this is the directory structure. It looks pretty good from what I just guessed looking at it. And then from here, we can go back in, fill in all the files, actually evaluate, test the code. I was pretty impressed actually with how far it got with just getting the directory structure and having those experiments that need to be ran. From there, I started doing some of the actual file generation where we're generating these Python scripts. There you kind of run into things where it's like, we don't have this code textbook data set. So there's kind of a lot more next steps that you would need to do. You'd want to be able to connect it to the web to get data sets. You'd want to do a lot more things there. But yeah, that was just kind of the main thing I wanted to see. Can we take a paper, outline its kind of the structure of what it did, get a file directory and fill back in these files? It's actually pretty reasonable to expect stuff like this to happen right now. Yeah, from there, I kind of left a few more things of like what could be better. So one thing, you could like pass in all the references that go into it. Right now it's kind of throwing all that out. You could actually pull in those papers, do some retrieval, get like better information to be passed in. It's all linear. You could parallelize a lot of this stuff. Right now for the code structure generation, it's just passing in a summary of the paper and the experiments that were ran. You could pass in the full text. It's just more and more calls. It's actually like kind of backwards. A lot more of the calls that go into this are on the prep side of like creating the experiments, the file structure. The actual CodeGen isn't that bad. I tried using GPT-4 and CodeLlama, the 34B from Anyscale. Tried it on a replit. The real issue is just that there's not much to run because you don't really have the data set for any of these. But it does a decent job at least like filling in the structure for the files there. But yeah, I think just, going forward, like, I feel like a lot of research will be kind of automated as you have like papers being generated. It's just one of the ways that you can actually validate the research is to actually drop the experiment, run it, evaluate it. see how it runs. And yeah, this was just kind of the first step to see how viable we are at with like today's LLM. Yeah.
So how do we get to actually running the code?
Right now it takes a paper, so it uses Archives API, pulls the text, and then it's just a whole bunch of linear calls. For running the code, you mean like running the actual files, or just like
running the code that executes the experiments in the paper? Yeah.
Oh yeah, that's the thing. You can't really run the code that executes the experiments because you don't have, like, it's not just experiments. It's going to try to recreate the whole paper, right? So for example, for the Orca paper, it's going to have to actually pull those data sets, try to fine tune a model. And that's kind of a limitation right now where you'd have to have like a person in the loop actually helping the model. It's not going to go full end to end and recreate the model. The paper, I feel like you could get there with a few cherry picked examples, but there's a lot more into that, and most of it's just you won't have the data. The pre-processing, it probably won't be zero shot. You know, like you can write a script to read what the paper did to pre-process its data. You can try it. But like it's a lot of steps there to actually go through. But right now, like the way I got to it executes it out to a replit environment, and you can like tie together these functions to try to run it. But yeah, that's kind of where you'd end up at.
Is there room here for like fine tuning with a corpus, like papers with code or something, like a parallel corpus of archive papers and accompanying GitHubs?
Yeah. I think that's like a pretty good point, honestly. Like papers with code, a lot of those things that have benchmarks where they actually have papers and their GitHub repos, that helps a lot in the directory like layout and everything, because it's kind of you're mimicking the style of how would this paper translate to a GitHub directory, what are the files we would get. So doing something like that with the code llama, pretty approachable there. And then you kind of have the same as just like people running their own experiments that are like putting out papers. You always have that constant loop going on, so you can just keep getting it better. Okay.
Any other questions? Right.
Cool. Do people still write code? Yes, sometimes. Maybe, kind of. Okay, cool. Sometimes I work with code bases that take much longer to run in their entirety in order to check if there's an error than it would to just pass the code base to a language model and ask if there might be an error. And so I wanted just a simple utility that I could import and run to make that check. And so I call this AI linter. Eventually, this could be a checkbox or something in an IDE like Cursor. And so what this does is we have a prompt. You are an expert, in this case, you're an expert programmer and debugger. Please read the following code file. Look for internal consistency and external consistency within the rest of the code base. Be alert. Look for subtle human errors where the code doesn't do what the function or documentation hopes for it to do. And then some instructions. And so we traverse the directory, read through every code file in the code base, and then if it imports any files, then we also attach all the related imports into one call at a time. And then we ask a language model to debug it. So I'll run this on this file. We have some scripts here with some sort of simple examples of things that would pass a linter, but would not actually compile, that would not actually run. Just some basic functions that are not actually, upon close inspection, correctly written. So here in main, I just have from modules import AI linter, and then before I run, I say AI linter.run, and then I run the rest of the file. So let's try that. Great. So this file works. Okay, great. So it found a few errors in this. It found an error with this function and a suggested fix. Found an error with this function and a suggested fix. I originally wrote it to actually create a new file with the edits and then replace that file. And it turned out to still create errors sometimes. We can't yet blindly trust language models to write code and then run it. And so I found it was more useful to actually just get the alert, and then maybe I can pass these instructions into Cursor or somewhere to take the appropriate debugging trips. So great, so it did its code review. All the improper functions have been identified. And these two ones, this one just passes. This is all correct code. And we're done. And now it can start the rest of the program. That's it. Yes.
So is this like looking, when you said linting, like is it like syntax errors, or is it like looking at like, oh, you could be applying a design pattern, or this is like algorithmically bad, or like?
Yeah, tongue in cheek. The ideal interface for this would be that it, like maybe LLM calls become cheap enough that you can just run this after every keystroke eventually. And so looking more at errors that would not be caught by traditional linters, but that are have missing internal logic or these other sort of human things that also take a lot of human RAM to track and debug. So that's the intention. Yes.
So is it following Pepe or Black, or like, how do you like set like the guidelines for like what the lint standard should be?
This is not intended to do the work of what is traditionally called a linter. This is like sort of the next abstraction layer about that.
Does it give line numbers? Can it get line numbers?
Oh, that's a good idea. I did not prompt it to, but it probably could. Right now, it just gives function names.
Yeah.
The ideal interface for this would be something like the right-hand side of the screen, built into cursor, where you can just click the function call, and then it provides the comments alongside the code. Yes.
You said that you try to put in the fix to the code and rerun it,
yeah.
And then you would sometimes get an error.
Yeah.
I wonder if you could recursively feed that error back and then just let it keep fixing. Have you tried that to see if you get a good result?
That sounds like automated code generation.
Yeah, it won't stop until it passes all the.
I did not try that. I will try that. It's got to go. Yes.
I was thinking like this seems really cool. Like one step that could get this to being an actual product that people would probably pay for is you allow this to be installed to like a GitHub org, and then you allow in the GitHub org you create a README where everyone dumps all of their opinions about how to write good code, and then you don't need to write, because we'll think of how many hours are spent in a larger org writing linter rules. You can just have an English thing where people can update it with their like whatever they want. There's like, don't do this, this is dumb, and then you have this thing just like be like the senior engineer that just like cracks down, and you can just call it like crackdown.ai or something. And, like you'd probably get like an SMB sale with that if you just demo that.
Nice. Nice. So saving a lot of what humans spend time doing.
Yeah.
Yeah. Arguing about. Sure. Yeah. Yes.
I saw we're using text DaVinci. Can you talk about models you said?
Didn't try it with other models. It's just default. No. There could be the next thing I would also want to try is passing the entire code base to larger context model, like Cline. It took some tweaking for it to recognize even within smaller scripts. So yeah. Crackdown.ai.
Okay.
Okay. Cool. Thank you.
Good evening. My name is Dmitry, and today I was working on Helm chart generator. I was using Kubernetes Helm, Artifact Hub, and Llama 2. Basic idea is get top packages, top help packages sorted by stars in Artifact Hub, add package repo, download this package locally, collect dataset, fine-tune code Llama 2, and make profit. But in reality, I managed to get data. It's about 1 gigabyte. I took 2,000 top Helm charts, and I started fine-tuning, but due to time constraint, I decided to slightly change the main idea. So we have YAML configuration or existing Helm chart, and we need to update, for example, README for this chart. So we put YAML template as input, and we ask CodeLlama to generate README-MD. And at the end, we receive this cool README-MD file we can put in our repo. And for example, for Minecraft server, it's a simple example. And I also tried to deploy something on Kubernetes today, and I just use this Helm install my release stable Minecraft, and actually it's failed. Yeah, I can show that amount of data is around 1 gigabyte, and I downloaded all top Helm charts, and yeah, I expect that I will continue this project and fine-tune my LLM on these Helm charts. Yeah, that's it. Any questions?
So what is special about the top Helm charts? Like, is it qualitatively very different from the others?
It's manually selected like stars on GitHub. It's like similar. Like if users like charts, they put stars on it, and you can sort by the stars, and probably it is good data to train or fine-tune your model.
So have you tried just like GPT-4 and just like generating without fine-tuning? And if so, like how has that compared to your fine-tuning experiments?
I think CodeLlama fine-tuned on these Helm templates will perform better.
And also, have you tried 3.5 fine-tuning?
Could you repeat?
OpenAI has fine-tuning for GPT 3.5. Have you tried that also?
I didn't try it because I have local GPU and I can train my models.
So I'm Erik. I'm working with Jesse from Morph on customizing language models for code bases. And so as part of that, we do a lot of fine-tuning. And I've gotten... Hey, did you guys hear what I said? Okay. We've gotten in just a lot of cycles. We've done a lot of cycles of fine-tuning language models. And we've noticed quite a few bottlenecks in the workflow of doing that in the iteration loop. So the basic iteration loop of training a fine-tuning language model basically looks like you generate data, which might be slow. You fine-tune a model, which is fairly slow. By the way, at a previous hackathon, I experimented with how to do distributed fine-tuning of LoRa models on just commodity cloud instances, which you can get a big speed up from. But this hackathon, I focused on how can you generate samples for evaluation really quickly. It's a really simple sounding thing, but it's surprisingly difficult to do in a convenient way. So one example is, imagine you train a code model and you think it's going to be the best code model ever. and you want to evaluate on human eval. But human eval has 150 questions. And so if you only have one GPU, how long is it going to take you to generate samples for all of that? Especially if you're doing like pass at 10 or something, it's going to take a long time. And then you notice that, okay, something's just wrong with the model. The model's responses aren't quite right. So you go back to your data set, you notice an issue, but you kind of wasted an hour. So why is this slow? The reason is just that inference is surprisingly slow on like normal, like not super good GPUs. And most people are finding just fine-tuning with just like one GPU. And actually doing inference fast, especially on a larger evaluation set in bulk, requires multiple machines. But getting multiple machines, especially multiple GPU machines, is a big, big hassle. And also just like orchestrating the machines to do whatever. There are like endpoints to let you do like serverless inference, but those generally don't support LoRa or custom models very conveniently. So my hunch was, or kind of insight, is that LoRa's are actually very cheap to distribute. So if you rely on LoRa's to do fine tuning, it should actually be possible to farm out a LoRa to a bunch of GPU instances or even CPU instances and run it in parallel at a large scale. So we prototyped this thing using a serverless platform, using a combination of GGML, llama.cpp to do inference of a fine-tuned code model on a CPU, and using Google Cloud Run, which can scale out a container image. And so the result is that you can have a very, very simple interface for running a LoRa fine-tuning. And you just run it over a big list of things, and you get answers. And none of this is running in the Colab notebook. This is all running on a service we spun up using this Terraform and this little server right here, which just calls out to GGML. So it actually is as simple as that. Now, this took like 30 minutes to run because I didn't have enough Google Cloud Run quota. But if you actually have the quota to do this, you can run like literally all of these things in parallel. And so you can finish your evaluation very fast. Human eval in 5 minutes. I think a simple improvement is it turns out CPU inference is still just kind of slow. Like you can't really do it in less than 5 minutes. But there should be a simple way to use something like replicate and use a GPU instance that you send LoRa weights to. And so that should let you do bulk inference on a custom model even faster.
Questions? Is this assumption here that the base model is already loaded onto those instances?
Exactly, yeah. So much of the overhead comes from like loading the base model. So if the community comes to revolve around a small number of base models, then I think there could be a very valuable service that's based on this principle. That based on the principle of kind of using a single base model as kind of a fixed cost and just running LoRa's very cheaply.
At like what size models does this become like more valuable to keep it loaded? Because the models aren't that big to keep spinning up. And another kind of separate question is how does it compare with like spinning up multiple parallel CPU instances for evals versus like distributed on like spot rented multi-GPU? Like if you go to like RunPod or anything and rent like a 4x like A5000 machine for like 2 hours and do distributed inference for your evals.
I think the answer to both your questions is similar, and the answer is basically like someone needs to figure out like how to maximize utilization. So with the size of the model, I think it's not the size of the model exactly that's important. It's whether the service is able to have the models be used at all times. Have the utilization be high enough not to have to like constantly spin things up, because that's where the overhead comes from. And then as for what you said with RunPod, that's kind of like one way that such a service could be implemented, right? Is on spot instances. So again, like how to manage that so that like you can get cheap spot instances while having that capacity and without like wasting money by having models loaded when they're not used. I think that's an interesting question, which I don't know the answer to, but I suspect like utilization is basically the question here.
Could you just like scroll to the top?
Yeah.
Cool.
Yeah, I guess my motivation for doing this is just like doing fine tuning a lot and feeling like why. So I used to be a front end engineer, and doing front end changes and the whole iteration cycle is just really fast. And so going from that to language model fine tuning, I was just like very
and like,
bored.
What size models are these that you're like comparing for the fine tune?
I'm doing 7 billion for this, but there's no reason in principle you couldn't do a larger model too. You just need slightly beefier instances.
Sorry, dumb question. How does LoRa or not LoRa help with inference speed?
Yeah, because like imagine let's say you wanted to do an extreme version of this and you want like to do inference on 1,000 things in 1 minute. With a big model, like it takes a long time even just to send the weights, to upload the weights from your training server.
Isn't that a one-time upfront thing?
Not if you're like training multiple. You're iterating on training models, right?
Got it. Okay.
Because every time you have a new model, it's going to be.
How much of that 1 hour was loading weights?
Huh?
How much of the 1 hour was loading weights?
Oh, not much. But that's if you're doing just one GPU. If you have one GPU, then the 1 hour is just spent on doing inference.
Okay.
But if you want to do it on like 10 or 100 GPUs, if you don't use LoRa, then most of the time would just be spent loading the weights.
And does any of this transfer to like if we want to run like a real inference server? Can we use CPU, or is this just specific to your offline use case?
Yeah, I think you can't really use CPU for like, unless you really use a lot of CPUs. It's hard to do it for like an actual like service for users because the latency is too high. But for this kind of evaluation, you can wait like a couple minutes for each thing.
Or offline things like tagging or classification.
Yeah, you can use CPUs.
Yeah. Sick.
Yes.
Slightly unrelated, but I wonder if you use LoRa versus standard fine tuning based on your experience with the models.
Yeah. So I think based on Robert from AnyScale also alluded to this. I think like LoRa is generally similar to performance to full fine tuning, except for situations where you have a ton of data. And I actually haven't really. My work has just been in situations where I only have a moderate amount of data, so I haven't had to do full fine tuning.
And I think what number of data points is that?
Like a couple hundred to a couple thousand, I think is fine for LoRa.
But if you have 10,000 or more, you would.
Yeah, I guess I haven't tested that yet.
It's
so I will say though that like, I think LoRa can be valuable even if you may need to do full fine tuning in the end, because doing LoRa lets you iterate fast. And so the key like determinant of your final model performance is the quality of your data set. So as long as your fine-tuned models give you good enough like feedback for you to continue to improve your data set, then I think it can be valuable to do LoRa even then.
Awesome. Crowd work.
All right. I built a coding agent for essentially Kaggle environments. I am sort of in love with Kaggle environments as a training ground for interactive coding, especially for data science. So first, what I built, this is basically like a little code interpreter that works natively inside of Jupyter notebooks in Kaggle environments. So the idea is if there is a Kaggle notebook somewhere that can be run on Kaggle, it can be run in this environment. And this agent can make changes to a notebook, it can create a notebook, it could manipulate a data set that you download from Kaggle and find some insights for you. And also, very interestingly for me, it could generate fine-tuning data for chain of thought reasoning on small models. So just a little demo of what this is. Here's our agent. We're going to run it. We are running a Kaggle Docker image or Docker container. So I'm going to ask this to do something really simple, and we'll just watch what it does in this notebook. Okay, so it's asking me to paste some Kaggle download code. I'm not going to import anything. I'm just going to show you right now what this does on its own. So what should I do? Show me NumPy A range. And then this is thinking of what to write in the notebook. And we'll see very slowly, because I haven't added streaming output. Oh, we'll see it wrote something. And now it's running its notebook so that we can see its output. That'll take a couple seconds because these environments are ridiculously slow. Oh, great, we got an output. So it looks like A range gives us NumPy array from 0 to 11 exclusive. So so then we can do lots of other things, right? We can go really ambitious. We could ask this to, let's say, train an MNIST classifier. Train. And then it will chug away. Now this agent, it works reactively. So it writes code, it can edit code that it's written before, it can read error messages as they pop out. And the idea is that it takes a goal, it tries to achieve it that you specify, and it will write the code wrong. It'll make errors, it will reference variables that don't exist, then it will have errors contained within this notebook when it runs it. And it will correct those one by one. And then eventually you will have something that looks like what you asked for. Now, while this runs, because it's ridiculously slow, I will show you what my dream is for what this will become. So right now I'm taking a notebook on basically nothing and asking it to create something. But I could also have taken a notebook on any one of thousands, I think it's tens of thousands or hundreds of thousands of public notebooks. And then I could have, like an example of this is a very popular beginner data set, Weedle's Cave. So you see they're doing a bunch of exploratory analysis, they're trying to take some statistics. And it's very interesting to me to make interactive llama to do reasoning in chain of thought. So one way we could make this is we invoke a chaos GPT. And this chaos GPT, it just sort of wants to ruin your day. I've told it, you are a Jupyter sabotager. You have been asked to introduce bugs into a Jupyter notebook. These bugs should preferably lead to errors later on in the notebook. So the dream here, and I cannot show you chaos GPT because I haven't set up the Kaggle data downloads, is it can create these errors, and then you put this normal Kaggle agent to the rescue. And we will watch this Kaggle agent try to fix these bugs and run the code without errors. And then when it succeeds, we add this to a data set of successful chain of thoughts. And then we can have this for real live environments that are representative of actual data science scenarios. And we can feed that to Llama, and hopefully that's a fantastic data set. Let's check up on how our model is doing. Oh, it's running the notebook. Yeah, sorry about this. Okay, in this case, no news is good news, because Jupyter notebooks in this very hacky, through a container scenario, they don't give you their output until they're done. So I'm going to actually make it cause an error. I'm going to Control-C, keyboard interrupt. Let's see if this, hopefully this shows us. No, it seems like, okay, anyway, no news is good news. This was running, even if you couldn't see it, I promise. Yeah, the idea is with better output, you can make an automated data set at a very large scale.
Here's what the VS Code color theme is. That's really cool.
Oh, this is jellyfish.
Worked at a company where that was a mascot.
What kind of model did it try to run on MNIST? Why did it, like, is it taking long? You said it's going to take long in this environment. Is that just like a byproduct of what you have, or like, did it just try to run a huge model?
Well, let me tell you about this environment. This environment is my computer. There's no GPU on this. This is like, this is running in some environment with like, yeah, it has no GPU access. This specific, the code I use to run Jupyter notebooks is like doing a double layer export. It's like running it inside of a second process. It's really slow. Yeah, it's like sort of the biggest problem I have to deal with. Yeah, so what does this model look like? Yeah, it's just sort of like a 4-layer MLP.
Will this model be able to compete on Kaggle?
Probably not. It's probably going to be pretty crappy.
So one of the most aggravating parts about Kaggle is just loading the data. As they should figure out how to do that for the more complex data sets, or do you think it would be able to?
Okay. First, no. The part that I can download from Kaggle is just the people's notebooks that they've made. I think there are enough notebooks on Kaggle, public notebooks, that I can just throw away the ones where the default Kaggle CLI download fails. And there will still be enough left to be a good training data set for reasoning. All right, thank you.
Hello. Okay. All right. So let me preface this with I just wanted to make a little silly project today, just something for fun to make me smile. So the project is called rizz-eval. The premise is that so I fine-tuned GPT 3.5 Turbo on my iMessages so that it would try to text like me, and I couldn't convince my friend to give me his texts. So the other model is just raw GPT 3.5 with a prompt. And so the premise of the project is the two models have a conversation with another instructed GPT 3.5 instance. And at the end, another GPT 3.5 instance is called to determine who has better rizz. So that's the nature of the project. I can try running it for you. It'll take a little bit. The first one that runs is what's fine-tuned on me. It's not perfect. It only had 3 epochs, and the data was not perfect. As you can see, there's the /u or whatever, not parsed out. And yeah, it's pretty sterile. I'm pretty sure it's because of the guardrails. And then yeah, the other one's pretty funny, I think. I prompted it to be really bad at talking to people, and so it says and a lot of filler words. Yeah, and then at the end you'll see the evaluation. Yeah, and at the end the conversation one is better. Go me. Yeah, that's the nature of the project. That's it.
Questions about how did you fine-tune the messages? Did you just download your folder?
Yeah. So the weird thing about it is Apple makes it really hard to get your data, and so the only way that this could actually be shipped as a consumer application is through the desktop. So you need to make a desktop app. They download it, but thankfully there was someone that already built an open source package called the iMessage exporter. And so all I had to do is run a command from the terminal, and then I got the data. So it's pretty easy.
How similar to your actual texting style do you think the fine-tuned model was?
So the first text is pretty similar, because it's just yo, what's up, or hey, what's good, or something. But I think for anything after, no. I'm not sure if that's because it hasn't trained enough. But yeah, it's my first time fine-tuning one of these models, so. Anyone else? No? Cool.
So we made the embeddings playground. Our thinking was before ChatGPT came around, we didn't actually build with AI at all. It was the launch of ChatGPT making it like way easier that made people realize what is possible and thus like start to build. And for us, one thing that we think is like really interesting, but there's really not that many good tools for, is embeddings. And so we decided to build the embedding playground.
Yeah, so I'll give a quick demo. Yeah, we work on like CodeGen tools on the side, so part of today was like testing our tools and seeing, like, making sure they actually work before we launch. So yeah, so go ahead and just give a quick demo. So it's actually kind of hard to hold here. How did you guys do? I'll just talk very loud. It's like it's pretty close. Okay, so so I come over here. So I'm just gonna like paste a list, some kind of basic stuff here. I can say like fruit over here. So obviously here you're gonna see it like all chunked together. That's not probably the most useful way. So I can come up here and just describe like the chunking method that I want. So in this case, I'm gonna say like new line and like 30 max or something. And so that'll change like how that all gets sorted, broken up into, so you just see the weights here, nothing too crazy. I can also like switch between models here. BG's sometimes works for us, but the API we're using kind of is, we keep blowing through our credits for it, so not today. But yeah, so so that's like one example. Let's say some other text stuff, like yeah, you can do like again, you can do like an essay and change this to like, there's also like a control you can change here, so you can see what that would look like 100. And so it's just like a nice way to be able to say like to be able to like just iterate on embeddings. So yeah, and then like, there's also like this like view code thing. So depending on how like kind of what settings you end up with, you can just copy this code and paste it to your app, which is pretty cool. So yeah, that's pretty much it. Cool. Any question? Yeah.
What's the search bar for? Like you said, it's new line and 30 max, but there's also
yeah. So these are also here. Yeah. So we wanted to have it like be like a little bit more generative, where you could like split based off. For example, if you have code in, you could say like chunk it based off like functions, paragraphs. So we got like some of it in, but it was like structured to the point for like where it was not as like code is what we're talking about.
This is pretty. What is your front end?
Oh, it's just React. I was a designer for
What are your secrets? What did you learn about embeddings?
Yeah, so first of all, we learned that like BG is way better than Ada, because like when the last time we used when we were first using embeddings, like we were mainly using Ada. We've been using G a lot more recently for our project, for like our CodeGen project. But yeah, like it's just like way more obvious when you're seeing it here. I wonder if like if I refresh, it's just we keep the API we're using. Let's see if we can get it. But it becomes really obvious, like, so try. Okay, so this is how you looking at. So yeah, we just keep going through them. But oh yeah, so like orange here, like it's like okay, yeah, it's like, you know, related to like fruits mostly, you know, and you see like lion is like down here. I don't know why dolphin, well, dolphin and lion are like pretty much equivalent in this case, like, but you know, carrot. I don't know why penguin's higher than lion, whatever. But so it's like some interesting things, right? But if I change it to actually this did like a little bit better.
Tiger's up there.
But yeah, tiger is like, you know, really far up into like I type the G or like whatever. So and there's like weird qualities like that. But yeah, Ada's just like much worse. It's like you get it a lot more as you're playing with like different examples. Yep.
What problem were you trying to solve?
Yeah, so mainly like we do a lot of like, you know, we use like playgrounds, for example, OpenAI playgrounds a lot to prototype. Even though we have it like all built into our app, it's like a lot of times it's just nice to be able to iterate on prompts faster. And so we haven't seen a good way to be able to iterate on embeddings as easily. Like, sure, yeah, you can just like do it in Python, it's fine, but it's just like if you're just trying to like like, and then for example, just having like nice control over how you're chunking and different types of data. Like, are you trying to categorize like different sorts of questions? Or are you trying to like find specific parts in like a code thing, like a piece of code? Yeah, being able to compare different models as well, super helpful, because different embedding models have different like strengths and weaknesses in different areas. So yeah.
I really like the inspiration of creating a playground, just like how ChatGPT created a playground for LLMs, doing it with embeddings. The thing that's unclear to me is like there's like embedding visualizers out there like Nomic for doing those embedding spaces and whatnot. What inspired the decision to choose this like strictly text-based visualization as opposed to something more spatial like that?
Totally. I think it's kind of like what Zubin was saying, where it's like, I think people, this is kind of like the probably like low and maybe also the other end of the IQ bell curve or something, where it's just like, you just type in stuff and you see it, right? But like ChatGPT is like somewhat similar, where it's like, you have like very like little control, especially early on, like of like what's happening. Like you can't set the temperature, you can't like, so it's like, yes, if you had more control, like you can get much better results. But it's just like, yeah, just at a very base level, for example, like being able to like just like have very like easy control over chunking. Like again, like I have like a design background, like well, not originally, but most recently. And so yeah, just being able to like iterate quickly on it is nice. I would love to have like more visualizations and stuff like that. Like it'd be super cool if you could just do like different projections in like 3D or something, or different bunch of stuff.
Part of it is like what you can create in the constraints of the hackathon.
Yeah. That's true.
So this is all in hackathon.
Yes.
All of it.
Yep.
Emphatic.
But made with Sidekick, which is coming out.
You can see our commit history.
You're allowed to write the code that writes the code.
What?
Are you allowed to write the code that writes the code? Yeah.
Yeah, exactly.
That is the existential question. We're back in that case. Yeah.
Cool. Yeah. Okay.
Yeah. I talked with some of you earlier today, and I had the idea of basically something like like a lot of projects do code generation for projects like small, for example, and just having a template to kickstart your project can be sometimes super helpful. So let's run that command. I worked on it from dinner onwards, so it's very new, but let's see how this goes. So basically the idea is it will create a new repository, and it will use a template that I'll show later on GitHub if I have time. But basically you see that here it created the Python template, and then it bootstraps the project to replace the files in place, and then hopefully it's going to create, so here I should have probably started there, which is basically you specify 3 things. I use the AnyScale endpoint that we were provided with, and just like the input would be just this objective. So here it's just create code to download data, train a machine learning model based on Iris dataset, and then put an API in front of it to respond to post requests with the predictions from the model. So a very simple case, right? So yeah, let's see how this went. I think it just didn't update this, so I'll just reload. Yeah, it's hard with the mic. So let's see, I think this one is stuck, but maybe if we look on the repository. So this one is the actual repository, and then it should have created right now a generated code and created a pull request with the code that we want. So this should have been pushed in the last minute, hopefully. Yeah, so we see here add generated code. So we see that here it created 2 files, one to train, one to predict. So something very easy, but then you get all the benefits of having all your code structure from like the Python template. So that means you'll get, like, for example, this repo is kind of an opinionated way of structuring your project with pre-commit and semantic release and the GitHub workflows and stuff like this. So it's basically an enhanced way of setting up a repo from a template. question.
So are you familiar with cookie cutter?
Yes.
So you would say this is like maybe like a natural extension of that, like cookie
It's
cutter
kind
is
of, yeah. Cookie cutter, I haven't used it in a long time, but cookie cutter, if I remember correctly, is based on like only your code structure. So it would like generate like your SRC folder or something along these lines. So here it's a little bit like this, but I can actually show you the Python template. So this comes from this repo, so it has, I don't know if you're familiar with a few of these things, but like usually this way it's like an opinionated way as well. As I put it, I don't know why it's zoomed in like this, but you can see that like usually you want to have like your code semantically released with like semantic commit lint. You want to have like your pre-commit checks, which for example like lint your code. So you see here it uses flake and isort and like all the things that Python would use. So it's kind of a cookie cutter, but it's also all the setup that you would have for like a language-based project. So here, it's like all the best practices that you would have for writing Python code. You put it in a template on GitHub, and then you bootstrap your project from that. So it's not only related to your code, but actually like your lint test build, as opposed to cookie cutter.
Which files is the agent aware of when it's writing, when it's adding code to the postcard?
So right now, because it's like I just like spent a couple hours on it, it just like looks at the core folder. So if we go back to the other repo, it's only gonna create the files, like the only files it modifies here. And you see, like for example here, lint fails, but the only files it modifies are gonna be within that the same name as the repo. Replace minus with underscores, and that's it. So right now it's only focused on like the equivalent of the SRC folder basically, and all the other files are going to be generated and kind of standard, and like your GitHub workflows and your release rc.json and all the stuff that you need to like release, then test your code. So ideally, I think the next step would be to also include like tests in like a test folder or something like this, but it's like it's only going to write files in like the equivalent of like the SRC folder and the test folder.
But is it aware of other files? Like, do other files get passed in the context?
Right now, no, but that would be great.
Oh, okay.
Take it away.
Yeah, so I know, thanks everyone for being so patient with a lot of presentations. I'll try to take as long as I can, but no. No, so real quick, like, basically, I just had this idea of like, what would happen if I described a bug, and then I let agents loose on our whole production repo set, and they just basically, they read all the code, and they figure out where they think the bugs are coming from, and then they just start pushing out a bunch of PRs to try and fix the bugs, like interns would if you're just onboarding like a huge group of them. And so it was kind of like, I didn't really know how far it would get, and I learned a lot along the way. So I'd honestly love to just like, I could answer questions, I could show the code, but I mean, you guys have gotten a lot of that. It was a fun journey. I think somebody had mentioned trying to do the higher context window Llama. So I had gone down a rabbit hole for a few hours of the day trying to get Llama 128K context window with Yarn, the Yarn method for extending the context. It was basically like a systems hell trying to get that working. And then I started realizing that like you can't just ingest massive files, because now you need to start bunching these up by functions and then repositories. You need to be caching things. So I could jump into the code here and like kind of show high level, but honestly, I think the easiest thing to do is just like, I'll give like 20 seconds of like, here's the top level flow, and I'll answer any questions people have. How far I got was I basically either have some debug flags of like repos, or I'll scan our actual production repos. I don't want to run that right now because it would reveal all of Banana's IP. So, but it does work. And then what it does is I can just show the code right here too. Where is it? Here. Sorry, that's a different.
Sorry, this is a different repo. Let me clear that. It's our God repo. Yeah, so this is why I don't do stuff in prod. Okay, let me just stay here and look at the code because I don't want to. we have this like admin repo that if I run it wrong, it'll nuke prod, so I don't want to do that. Basically, it'll scan all the Git repos, and then it'll pass in all of them to GPT-4, and it'll open like a conversation, and it'll start having this like discussion about like, hey, here's a bug description and a repository name. Can you help determine if it's likely that the bug would be in this? And so what we did was, most people when they try to solve this problem, they actually scan the code first. And so I tried this, but then it leads to this explosive problem of like there's tens of thousands of lines of code. If you scan the readmes of the repos first, they explain enough about what the code does that you can use that as an approximation, and readmes are typically short, so did that. I guess one final thing I'll say is, I didn't get to the generating pull request yet, but I realized that one of my friends, Keerthana, at a previous hackathon at AGI House, did sweetpt, which is like the software. They basically generated pull requests, so I'm going to wire that in next. And then, yeah, basically, we'd have everything. That's all. Any questions? Intern deploy. Thank you. Cool.
Okay, give yourselves a huge round of applause.